is Anthony from mycodeteacher.com, and in this lesson I'm going to show you how to use the accelerometer for your iPhone applications. I've noticed from talking to a lot of amateur developers or developers who haven't actually even started writing programs for the iPhone that a lot of people assume that using the accelerometer for the iPhone is actually a very complicated task, that it requires other frameworks and a lot of code. The truth is, using the accelerometer or accessing the movement in the accelerometer in the iPhone is extremely simple. It only requires a very little bit of code, and Apple has really done basically all of the work for you. The only situation in where using the accelerometer becomes complicated is when you have an application that does a lot of math with the numbers that come from the accelerometer, but from actually getting movement in the X, Y, and Z axes is actually very simple. So let's get started. I have Xcode open. Let's create a new project. Window-based, of course, because that is the simplest and that's all we really need. And I'll title it Accelerate. So first, let's open main-window.zib. So what we're going to do here is we're going to put 4 UI labels on the window. 3 for the last or most recent movement in X, Y, and Z axes, and a 4th for total movement. So we'll just add up all the acceleration. So let's create those labels now. So we will select them all and center them. Vertically and horizontally. Now, as you might have guessed, we need to actually connect these to outlets or instance variables for our Accelerate app delegate class. So let's go back to Xcode and go to the Accelerate app delegate.h file and add some IB outlets. UI label X label, IB outlet UI label Y label, and IB outlet UI label Z label, and a 4th for total acceleration, IB outlet UI label total. Now let's save this and go back to Interface Builder and connect these. So of course, right click and drag from label 1 connected to X label. Same thing for label 2, Y label, label 3, Z label, and the 4th total. Now let's save this and go back to Xcode. So that should be all we need to do in Interface Builder, so everything else now is code. So let's look at the documentation for a minute. Let's take a look at the UI accelerometer delegate. So we have here a delegate method, accelerometer.accelerate, and what we want to do is we want to set the delegate of the UI accelerometer class to our application delegate so that it will receive messages in this form when some acceleration occurs. Now, it's going to be sending messages continuously, very quickly, over and over again, because the accelerometer is always going to be moving a slight bit. And even when it doesn't move, it still sends these messages. So you might have asked yourself, well, what accelerometer or what UI accelerometer object are we going to set the delegate of? The answer to that is at the launch of each application, there is a shared accelerometer that is instantiated as soon as the application launches. So every application has a shared accelerometer or an instance of UI accelerometer that retrieves the movements from the actual hardware accelerometer and sends it to its delegate. So if we take a look at the UI accelerometer class, we have here a class method shared accelerometer, and it returns a pointer to the system-wide accelerometer object. So as you can see in the discussion, do not create new instances of the UI accelerometer class. So this is not meant to be instantiated multiple times. There's only one instance needed. So now let's close the documentation here and let's set that shared accelerometer's delegate. So UI accelerometer shared accelerometer set delegate self. So what we've done here is we've told the system-wide accelerometer class to send messages to this object that we're working in right now. So tell the accelerate app delegate object when the accelerometer moves or when some acceleration occurs. Now let's go back to the documentation and take another look at that sole UI accelerometer delegate protocol method. So when some acceleration occurs, the accelerometer, the shared accelerometer, sends a message in this form, accelerometer, and then it sends itself, did accelerate, and then it sends an instance of an object called UI acceleration. This UI acceleration object has 4 properties. One for movement in the X axis, one for movement in the Y axis, one for movement in the Z axis, and a 4th for the timestamp of that acceleration. So now let's actually make use of that delegate method. Void accelerometer, UI accelerometer did accelerate UI acceleration. And so now we can simply set the text of our 4 labels using this here. So first we're going to do it for the X, Y, and Z labels. X label text equals, now we need to pass in a string, and of course, as you might imagine, the properties for the UI acceleration class are all float, not string, so we need to create a string with the following format. Send F for float, acceleration X. Do the same thing for Y. Same thing for Z. So now we need to do an extra step for adding all of these up and storing that in the 4th label. So let's just build this and make sure everything's working here. Now I'm going to have to build this to an actual iPod Touch because when building this on the simulator, of course, your Mac, MacBook, iMac, whatever you have doesn't have an accelerometer, so of course nothing's going to change. So what we need to do here is test this on an actual iPod or iPhone. This might take a little bit. Because it's actually installing to an iPod Touch. Okay, so now you can see there, it's hard to see because the font's actually quite small. Now the font is being resized because UI labels try to fit in as much as they can before truncating. So they'll make the font size smaller if there's too much or the text you're passing in is too long. So what we're going to do now is let's actually kill this application and make it so these labels are not resized. So we can simply just make them larger and center. Okay, now let's just use the size panel and just copy that width, 209. Do the same thing for all 4. So now let's save this. Now, you may have noticed here we have a warning. Warning, class Accelerate App Delegate does not implement the UI Accelerometer Delegate protocol. So now, this class actually does implement the UI Accelerometer Delegate protocol, but Xcode here isn't sure, or the compiler isn't sure, because we haven't actually filled that out here, and we haven't listed it as a protocol that this object promises to implement. So here in these brackets are all protocols that this object here is going to implement. So let's add the Accelerometer App Delegate, or Accelerometer Delegate protocol. So now let's rebuild this and check again that we fixed those last 2 issues. So now, as you can see, text is not being resized. And you can see the first 3 labels are constantly being updated. So the shared accelerometer is constantly sending messages to its delegate, which happens to be our Accelerate App Delegate class. So let's kill this again. And now, let's fill out that 4th label. So we need another instance variable, something to track total acceleration. So float total acceleration. You can save this, and now let's go back to the delegate method here. First, let's add to the total acceleration instance variable that we just created, plus equals acceleration x plus acceleration y plus acceleration z. Now, we don't want this to show any negative values. We just want the gross absolute value of all this acceleration. So basically, gross movement. So we're going to absolute. We have a C function, float absolute, which returns absolute value of all this. And now, let's set the total labels text to a string with the format %f, and let's fill in for that %f the total acceleration instance variable. So now let's build this final time, and our Accelerate app should be complete. And there you have it. You can see the first 3 labels are sometimes positive, sometimes negative, depending on the last or most recent movement of the accelerometer. And the 4th label is just increasing constantly, and will do so forever until a memory overload is reached. I'm Anthony from mycodeteacher.com. I hope you enjoyed this lesson. I hope you tune in for future lessons. Thanks for watching.